This is Mr. Mahmoud Abdullah. I'm going to teach you biology today. We have a new lesson, which is DNA, RNA, and protein. I know that you did study DNA before, so you have some information about it. Today, mainly, we're gonna focus on the RNA. And because you have a previous knowledge about the DNA, I'm going to ask you some questions about the DNA. Look at this figure. What is the figure? What's in the figure?
Flower.
Flowers, perfect. What do you see? Yeah.
Okay.
Sorry?
Okay.
Okay. Yeah. What else?
Flower.
Flowers. Here I notice the presence of different colors. Am I right? What causes the different colors in the plants? Yes.
Pigments.
Pigments. Perfect. Who knows what's meant by pigment? We have lots of pigments, even in our bodies, by the way, like the tattoo. Tattoo is a pigment, yeah? Even your skin color is caused by a pigment, yeah? What is pigment? Who knows? Yes?
It's a molecule that absorbs light.
Molecules that absorb light. It's a specific one. You mean the chloroplast. Chloroplast in plants, yes, which is specified for absorbing light. But the pigment in my finger over there, the tattoo here, reflects light, but it doesn't absorb it. It absorbs also. But this is not the function, by the way. What causes the presence of different pigments here? The pigments, different genes. Different genes, perfect. Different genes. The gene is made up of what? DNA. Good. That's one. The plants. What do you see here? Huh? Twins, yeah? What did you say? Sorry? Twins. They are black colored, yes? They are exactly the same. What causes the twins? They have the same genes, exactly. So their origin is only one sperm cell, fertilize one egg cell, and later they divided into two different eggs, two eggs. But the internal component inside it, which is the DNA, are the same. That's why they became identical twins. Okay. What about this one? Are they twins? No. Oh, they are brothers only.
Different twins.
How do you know? How do you know that they are brothers? No. Huh? They're different in size, yes? They are different in size. But they look approximately the same. Similar traits, good. So when you look at them, the same skin color, approximately the same skin color, approximately the same hair color, the structure of their bodies are approximately the same. Yes? So what causes that? Genes. The genes are made up of DNA. Good. Here, I have sheets with 3 groups. Each group is going to take a sheet. Each group is going to answer the sheet depending on the previous knowledge about the DNA. Okay? Start. All together, okay? All together. Start. You have 2 minutes to finish it. Don't answer.
I have the very
It's not important.
Is it okay?
Yes.
You need more time?
It's fine.
Yes, on this,
Did you finish?
yes.
Which group? Group 1. Yes, 1. What do you answer? Read the question and then the answer.
In figure 12, what was the 8 decency stand for?
Yeah.
Our group answer was it stands for nitrogen spaces. A is added in, T is type in, 6 is in, done.
Good. Perfect. Perfect. What about this group? Did you finish? Stanley. Stanley, sir? You finished? Give it just to in the page. You read it? Yes, read it.
The answer
Yes.
in nucleotide gives us specific information.
Now
to
we
the
do.
DNA. The DNA transmits and copies information.
That's good. Perfect. Yeah, perfect answer. Good. It's your turn now, so I'll interest you. Your turn. Both. Yes.
The first one, I identified the three main components. First, the phosphate
Yeah.
deoxyribose sugar, and the nitrogenous base.
Good. Next.
The covalent bond keep the deoxyribose sugar phosphate group and nitrogenous bases together, but the hydrogen bond is weaker than the covalent bond. So they are used for the nitrogenous bases.
Yeah.
So to be able to start the DNA replication.
Aziz, do you agree with him?
Yes.
Okay. Can you repeat the second question, please?
What are the roles of covalent bonds and hydrogen bonds in the structure of DNA? So covalent can keep the oxygen bond sugar.
Is there a problem? You cannot read the
Yes.
photograph? Yes. Try.
What are the roles of covalent bonds and hydrogen bonds in the structure of DNA? Covalent bonds keep the deoxyribose sugar, phosphate group, and nitrogenous bases together.
That's good. Perfect. Now, let's get to our lesson today. We're going to talk about the DNA, RNA, and protein. Okay? From the knowledge that I got, now I can start talking about the RNA easily because you have lots of information about the DNA. First of all, you have to differentiate between three different processes. The first process is replication. The second is transcription. The third is translation. Okay, I'm giving you the chance only for 1 minute to answer, to get an answer or an idea about the difference between the three processes. In your own paper, you have only 1 minute to finish the difference between the three concepts. Your own ideas. Try it. Each one is working individually. Each one is going to work individually. You can discuss, but I want to see the answers on your own papers. Is it okay? Each one individually. 30 seconds left. Let's start. Stop. Stop. Leave the pen. Leave the pen. Listen to me carefully. Muhammad Wa'ad, what's meant by replication?
Reading of DNA.
Making a copy
Of DNA.
Perfect. Making a copy
DNA.
of DNA. Good. Next, Abdulaziz. Faisal. Yes. What's meant by transcription? Making a copy of RNA. Perfect. The last one, translation. Translation is
Transport information.
making what?
Protein.
Making a protein. Perfect. Making a protein. Each one of them is a different process that takes lots of steps to be done. But if you know the difference between replication and transcription in a short idea or in the short words, it's going to be easy for all of you. Replication, making a copy of DNA, another copy of the DNA. Transcription, making a copy of the DNA to make what? RNA. The last one is translation, means to form protein. The process of making replication to form mRNA that is going to be done in the nucleus, leaving the nucleus through the pores in the nuclear membrane to the outside to reach the ribosome. The ribosome is going to take the message from the messenger RNA and convert it or translate it into a protein. The protein itself is going to make the pigments that make the boys, do you remember the boys, the twins? That make them black, like the melanin. And also that make different flowers, that make different structure of your body. All of them are included in the DNA. Okay? Here, comparing the DNA and the RNA. Actually, there are three different things that make the DNA different from the RNA. Mahmoud, can you read the first one?
There are three important differences between RNA and DNA.
Yes. The first one is
The sugar in RNA is ribose instead of deoxyribose.
good. Ribose in case of RNA.
Instead of
Deoxyribose in case of
DNA.
DNA. Perfect. The second one, Muhammad Yahya. Hazim? Yahya.
RNA is generally single-stranded and not double-stranded.
Good. The DNA is double-stranded, double helix. We can say that. But the RNA is only one strand. And the final one, Nasser. The last one.
RNA contains uracil in place of time.
Oh, good. Talal, how many nitrogen bases we have? If you get it,
38.
you're gonna take one for your answer.
4.
4? Do you agree? Yes? 5. Okay. So you said 4. What are the 4?
Adenine,
What are the 4 that you mentioned?
adenine, guanine,
Adenine, guanine,
thymine,
thiamine,
cytosine.
cytosine. Perfect. That's good. You said 5. What's in the 5th? Uracil. Clap to him. Very strong. Clap to him. You are 5. Actually, you are 5. 4 of them are located in the DNA, in the RNA, one of them is going to be replaced, which is thymine, is going to be replaced by that uracil, which is one of the differences between the DNA and RNA. Here, we can easily differentiate between the two different structures. DNA and RNA. Good. Function of RNA. Actually, here we have to differentiate between the different forms of RNA. Different forms of RNA. How many forms in the RNA? Abdullah? How many forms in the RNA?
Three.
Three forms. What are they? Okay, I'm telling you. Actually, there are three. The first one is messenger RNA. Messenger. I'm going to write it here. mRNA. The second one is ribosomal RNA. The third is transfer RNA. Okay? The word ribosomal. Can you give me an idea about the abbreviation RNA? Yes? Ribonucleic acid. Perfect. Ribonucleic acid. We have to put them in capital letters, like you see here. Okay? But to make a difference between the word messenger and the abbreviations RNA, we have to put the messenger in a small letter. Okay? So messenger RNA, ribosomal RNA, and transfer RNA. Is it clear? Okay. So the process of transcription, which is making a copy of the DNA, making a copy of what? Sorry, a copy of RNA, making a copy of what? Of RNA, is very important process to start forming the protein. The process of forming proteins, you are going to see it now. Listen carefully, guys. What about the sound? No problem. It's not working here, yes? Good. So I have three different papers also, three groups of questions. I'm going to distribute them, and you have to put your own ideas in it. After that, you're gonna see a video about the information, the process of transcription. Then you're gonna answer the question again. Okay? The first one, second one, third one. Don't write anything in it, okay? Just take an idea about the questions. You should be close, okay? Questions? Now you have an idea about the questions, okay? Is it okay? start the video? Yes. Guys, look at the board. As you see here, this is the cell. Guys, listen again. This is the cell. And while we're getting inside the cell, we're going to see lots of organelles. This one, which is here, is the nucleus. Inside the nucleus, there are the DNA. This is a chromosome, which is made up of 2 chromatids. When you focus inside it, you're going to see the double helix, which is surrounding the histone, a kind of protein that protect the DNA itself from being coiled. When you focus on it, you find that the double helix is made up of double strand here. Let's focus here. This is the DNA as you see. Yes? Is it clear? Yes. Which is made up of double helix. This is a helix and this is number 1. The inside structure is called nitrogen bases. How many nitrogen bases we have here? Only 4. Actually, there are 5. But in the DNA, there are only what? 4. Here we have the guanine, adenine, thymine, and cytosine. They are connected to each other by a rule called base. Ibrahim. The rule is what? Huh? Base pair? Huh? Base pair. What does it mean? It means that the adenine is coming with that thymine, perfect. And the guanine is coming with that cytosine. And the opposite. So when you see adenine, obviously the opposite will be thymine. When you see guanine, the opposite will be. What about the bones here? The name of it, hydrogen bones. Perfect. Hydrogen bones. But how many hydrogen bones are located here? How many here? Perfect. 3. It means that the strength, guys, Allah, are you with me? Okay, listen to me carefully. The guanine cytosine relationship has how many hydrogen bonds? Lovely. 3. Perfect. The adenine and thymine has how many? 2. Like 2 hydrogen bonds. Perfect. So the connection between the guanine cytosine is stronger than the connection between the adenine and thymine. Is it clear? Yes. Good. So here, look at the colors. The red comes with the green, so the green comes with red. Okay? Here, the blue comes with the white, the yellow, and here the yellow comes with the blue. Okay? Perfect. So adenine comes with thymine, guanine comes with cytosine. Let's go. What about this brown thing, the large brown thing here?
Ribosome and RNA.
Right, perfect. Ribosomal RNA. It's an enzyme that's making a specific function. What is the function of it? Huh? Unzip the what? The DNA. Perfect. And then
Make the RNA.
make the RNA straight. Good. Let's focus. What's going on here? Here the thymine, the nucleotide, which is existed in the nucleus, is going to be attached to that thymine. So adenine is coming with thymine. Uracil is coming with the uracil is replacing which one? Thymine, perfect. The T, thymine. And here the G comes with, then the C comes with G. And you can imagine the next, the A comes with T. The G here requires what? C. It's coming. What about the T? A, and so on. Okay? So after a while, you find that they are building mRNA, messenger RNA. Let's see. Good. The enzyme is going to making the process of unzipping and build the mRNA messenger RNA. This structure, as you see, is only one strand, contains uracil instead of thymine, and also the sugar that form it, which is located here in the nucleotides called sugar ribose instead of sugar deoxyribose. Clear? This is the messenger RNA. A process, this is called, by the way, pre-mRNA. A process of modification will occur later inside the nucleus, and then they are going to leave the nucleus through the pores. Do you remember the pores in the nuclear envelope? Okay, they are going to leave the nucleus to reach the cytoplasm. In the cytoplasm, there is a structure called ribosome. Perfect. Yeah. What's happening here?
The mRNA is going out of the nucleus.
Good. These pores, as you see here, is the place where the messenger RNA get out. Then here, they reaching this structure. What is this structure? Ribosome. The ribosome is made up of 80 different kinds of protein plus ribosomal RNA, specific kind of RNA, called what? Ribosomal RNA. And it's made up of 2 units, 2 subunits. They are attached to each other, and the mRNA is going to enter through them. Okay? Let's go.
tRNA.
Oh, something appeared here. We said that how many different kinds of RNA we have? 3. The first one is messenger RNA. We studied it before.
The second one.
Now the second one, which is
tRNA.
oh sorry, there is another one,
Ribosomal.
ribosomal RNA, which is a part of the structure of ribosome. From where? From it takes the name ribosomal, the ribosomal DNA and the ribosome, ribosomal RNA and ribosome. After that, the
tRNA.
third one is tRNA. The transfer RNA contains anticodons. You know that the codons are 3 letters, yes? 3 nucleotides. The anticodon is the same. Let's see here, there are also 3 nucleotides. Okay? And they have their own structure, the special structure. And at the top of it, there is amino acid. It is what? It is what? Amino acid. Perfect. It's complete. Good. Oh, what's happening here? Here we have to stop. Look at this structure. The mRNA contains codons, which is made up of 3 letters by 3 letters. Okay? Also, the tRNA is made up of anticodon, the opposite. So, if you have here G, the opposite must be
C.
If you have here U, the opposite must be If you have C, the opposite must be
G.
codon and anticodon. Is it clear? It's going to leave the amino acid and move away. The amino acid is going to connect to the next amino acid by a peptide bond. By what? Peptide bond. Take care that here we differentiate between very different kinds of bonds. The first one is covalent, yes. The second is hydrogen, and both of them are located in the DNA. Here we have a new one. The bond which is attaching the amino acid with the next amino acid called the peptide bond. With what? Peptide bond. Here. The codon again, the anticodon, the codon, the anticodon. Notice that here we have U, and we will never see the letter T because it exists only in the DNA. It's complete. Oh, when it leaves the amino acid, the next step it's going to leave the process of translation itself. Look at this one. A long chain of amino acids. So here, how many amino acids do we have? How many amino acids? 20 amino acids, perfect. They are like the alphabet letters. 20. The different arrangement of the amino acids making what? different proteins. Each protein is specialized for doing a specific function. Proteins are specialized. Okay? This protein. Oh. Now they are folded, forming the protein. Specific protein. Good. Now, I'm giving you 2 minutes to finish the paper with the sheet in front of you. 2 minutes only. Yeah, discuss the topic. Give me 1 minute because there is a point that must be clarified. Okay? Okay. I said after the process of transcription, the mRNA is called pre-mRNA. Yeah? It means that it's not ready for starting the process of translation. This process occurs inside the nucleus, the process of erasing some parts of it. The DNA with the mRNA is made up of exons and introns. Look at this one. This is the DNA and this is the RNA transcribed. The same, exactly the same. But something is going to happen. The intron is going to be erased. And the rest will be the exons only. This one is the final mRNA. Final mRNA. That's going to leave, look at this one, is going to leave the nucleus through the nuclear pores. Is it clear? Start again. Start again. Time? Okay. Read the answers. Loudly. Listen, guys. Loudly.
According to figure 15, we want to what proteins specifies the amino acid and GDC.
Yes. DGA, GGG, DGA, GC, and GGU. Yeah, perfect. Then
how many amino acids?
Loudly.
How many amino acids could be
Specified as
if proteins consists of two molecules?
Can you read that? Yes. Put it right. Put it right. Yes. Read it loudly.
How many amino acids could be specified if codon is consisted of 2 nucleotides instead of 3? What problem will this present from combination making proteins using all 20 amino acids?
Good.
There will be only 16 combinations in the nucleotides. There will be no enough combinations for an amount of 20 amino acids.
That's perfect. Yes. It's your turn.
What is molecule B? The molecule B figure 386. And what is its function? tRNA, it carries the amino acids to the ribosome.
Good.
What are the three main parts of an RNA nucleotide?
Yeah.
Ribose sugar, phosphate group, nitrogenous base.
Good. No. That's enough. No. Yes.
mRNA provides the code for translation. RNA reads the code. tRNA brings the next amino acid that is specific for the code.
Okay, good. The last thing, look at the board, guys. The last thing in our lesson today is how to read the codon. How many nitrogen bases we have? 4. We have only 4 here. Okay? So, the G, U, A, and C. This is in case of what? RNA. In case of what? RNA. When you start reading, you're going to start from the center of the circle to the outside. So here you have G, U, G. The U has how many alternative choices? 4. 1, 2, 3, 4. Each one has also 4 choices. 1, 2, 3, 4. Yes?
Yes.
Okay. So the codon is how many letters? 3 letters. Perfect. So when you say U, G, G, it refers to a specific protein. U, G, A, oh, stop. It's right. It's really nice. Stop. Stop means what? Stop codon. It means that the translation will stop at this point. Or at this codon. Okay? That UGC and UGU, all of them are the same codon for, or are different codons for the same protein. Different codons for what? For the same protein. It means that maybe one protein could be identified by more than one codon. The answer is yes. This is the way that we're gonna use to read the codons and the anticodons. At the end of this period, I want to say thank you very much, and the homework is going to be identified, inshallah, after 1 minute. Thank you very much.